Hello, everybody. I'm Rebecca Vital from Shenkar College of Design and Engineering from Israel. I'm coming from an architectural background. I'm not an archaeologist, but I think that what we'll see here is the same methodology and the same way of thinking, whether the building is 60 years old or 1,000 years old or 2,000 years old. The project that you will see was done within a framework of a preservation course, and it was done with a group of students. And the question was here, the building that we're talking about was a building under preservation with a question mark with whether it will remain under preservation or not, but it was a cultural heritage site because it was an integral part of the Israeli history. And the question when we talked with the project architect of the city was what was the best way to document the site. The building in question is a single family residence in the area of Ramat Gan, which is adjacent to Tel Aviv. And the reason this building is an important cultural heritage site, it served as the primary residence and as the headquarters of David Ben-Gurion, who was the first Prime Minister of Israel during the War of Independence in 1948 and during the establishment of the State of Israel. It's a simple, relatively simple house of 270 square meters, and the house is labeled for preservation. For somebody who knows Israel a little bit, here you can see the location of the house. This is the greater Tel Aviv area, and what you see in red is the city of Ramat Gan, which is exactly adjacent to Tel Aviv, and the house is located within Ramat Gan. It's a two-story house. And the reason that I said the building is under preservation with a question mark next to it is because the owners have petitioned the fact that it's under preservation. And the simple reason is that the area, the lot right now is zoned for a different capacity. It has the capacity to have 1,400 square meters rather than only 270 square meters, and they can build 7 apartments instead of this house. So if it will actually, the petition of the owners will go through, the building is going to be taken down, which means that an interesting part of piece of Israeli history is going to be erased with it. So we suggested to the city of Ramat Gan to do the documentation through laser scanning. Because when we need to document a building of cultural heritage, there is a lot of things that we need to document. It's the three-dimensional geometry, it's the material, the orientation, the context of the building, and on top of that is all the historical background that comes with the building that needs to be documented, and we want everything to be in one comprehensive database. So we used a Leica Geosystem C10 scanner to do the documentation, and then later on we did the post-processing of the data in Leica software, which is called Cyclone. You see the equipment here on the picture. And to scan this building, we had to take 72 scanning locations in the interior and the exterior of the house. On the exterior, we scanned in medium resolution and we took photographic imagery. In the interior, we just needed to scan in low resolution, which was accurate enough. The reason that we have this many scanning locations is that we didn't have the option to use GPS referencing here, and we didn't have a total station as well to do topographical surveying of the site. So to connect and register all the scans, we did a large amount of scans. And what we received is a point cloud which has all the geometrical information, and on top of that we can superimpose all the picture information that we have for the site that the scanner takes. And what you see here is the different views of the cloud point, the point cloud. And very fast, once we have this objective database, we can do a fly through the cloud point and see the geometry and understand immediately the 3D geometry of the building. The important thing about this stage of work is that it's an objective database. It's a database that the hand of the architect or the archaeologist or any interpretation, there is no interpretation to this database of anybody. So it's completely objective, and that's what we call our raw database about the building. And then there are many theses or hypotheses taken and next steps about the continuation of this stage of work. And we can go from the cloud point, we can go to two-dimensional drawings, we can go to a three-dimensional model, we can work for preservation, and we can create a virtual reconstruction. Now what you see here is a few forms that the point cloud can take. It can be viewed with an intensity map on top of it, which is a combination of the return of light that the surface gives and the color of the surface itself. It can be viewed as a grayscale, or it can be viewed with a photographic imagery superimposed on top of the cloud point, which goes and colors each and every single point of these millions of points that we have in the database. And then we took each elevation of the building and we created two-dimensional drawings. This is already a stage in the post-processing that we interfere. The hand of the architect goes and traces over on the top of the point cloud to get out information. We can see here the point cloud superimposed with the two-dimensional drawings and the layering of the point cloud that we took to compile this elevation. We got a better understanding about the built-in elements of the building, which in the first view when we walked inside the house we didn't completely understand. And we have a documentation of all the smaller elements that compile this structure. On top of that, we had photographic documentation of the materials that are on the site. We have a three-dimensional documentation of the interior elements of the house. And we divided it according to the functions of each area. There are many ways of viewing the information. Here you see an axonometric cut into the point cloud and the 2D drawing superimposed on top of it. So we got all the elevations and all the sections. Certain elevations had extensive stonework where we were able to document it very accurately and for preservation purposes make an assessment on what's the work that needs to be done. Also, the stucco work was very damaged in certain areas, and we were able to get an immediate assessment of cost and quantity for what it needs to be fixed. But in case the owners will get their way and they will turn this building down, we were able to create a three-dimensional model of the building, which represents the building when it was first built. We can superimpose and mix this three-dimensional representation with the point cloud, so we can see exactly the differences of the as-builds that we have from the site today and from the reconstructions that try to look at the building when it was first built in 1944. So by creating a three-dimensional representation, if this building is going to be torn down, it can still be part of this historical era that this building belongs to, and it can be part of the historical narrative that accompanies the time period and the first Prime Minister of Israel. And it's also a way for the layperson to understand the building, especially in the case that the building does not exist anymore. You can give this information in a very clear visual way. This is it. I just want to take advantage and make a small announcement. We did this year in Israel for the first time a workshop on laser scanning, it's a 4-day workshop that takes the participants through all the steps of the laser scanning process and the post-processing with the software of Cyclone, so people get to know the equipment and work with the equipment, and then they get to post-process the information to 2D drawings and to 3D meshes. We did that in the archaeological site of Metzada, which is an archaeological site from the Herodian time period in the desert. And we will be doing this for the next 2 years as well, so the next workshop is next February. If somebody would be interested in something like this, I would be happy to put you on our mailing lists. Thank you.